Before skyscrapers, highways, and megacities, there was dirt, rock, and terrain that had to be conquered. In the 1960s, bulldozers became more than machines. They became the backbone of modern civilization, built with raw steel, massive engines, and zero concern for comfort. These dozers reshaped landscapes long before computers ever touched a job site. They pushed mountains. They carved highways. They made the impossible possible. Today, we're counting down the 10 bulldozers from the 1960s that built the modern world. The iron giants that laid the foundations for everything we rely on today. Watch closely, because without these machines, modern life wouldn't exist. Number 10. Caterpillar D6 1960s variants. The Caterpillar D6 of the 1960s may not have been the largest bulldozer of its era, but it was arguably the most important. This machine earned its legacy not through sheer size or record-breaking power, but through absolute versatility. If a road, pipeline, dam, military base, or industrial site existed in the 1960s, chances are a D6 worked on it at some stage. What made the D6 so critical was its perfectly judged balance between power, weight, and durability. It was strong enough to handle serious earth-moving tasks, cutting roadbeds, backfilling trenches, clearing land, and shaping embankments, yet compact enough to be transported easily and operated in confined or uneven terrain. This made it ideal for infrastructure expansion into remote regions where larger machines simply couldn't go. Mechanically, the 1960s D6 was a masterpiece of reliability. Its diesel engine was designed for long, uninterrupted working hours, often running all day with minimal downtime. The drivetrain and undercarriage were heavily overbuilt for the machine's size, allowing it to survive continuous shock loads from rock, roots, and hard soil. Tracks, rollers, and sprockets were built to be repaired rather than replaced, keeping projects moving even in isolated locations. The blade and hydraulic systems were purely mechanical and hydraulic, giving operators direct feedback through the controls. This connection between operator and machine allowed surprisingly precise grading and finish work, which is why the D6 was used not only for rough clearing, but also for shaping foundations and road surfaces that still exist today. The Caterpillar D6 didn't dominate headlines, but it dominated job sites. Its reliability, adaptability, and global presence make it one of the quiet builders of the modern world. Number 9. International Harvester TD15. The International Harvester TD15 represented a very different philosophy from lighter, more versatile bulldozers. This machine was built for raw, unforgiving work, where pushing power mattered more than finesse. In the 1960s, as dams, highways, and industrial complexes expanded rapidly, the TD15 became a trusted weapon on the toughest job sites. At the heart of the TD15 was a massive, slow-revving diesel engine designed to deliver relentless torque. International Harvester engineers intentionally avoided high RPM performance. Instead, they built engines that could pull hard hour after hour without overheating or tearing themselves apart. Thick castings, oversized bearings, and conservative tuning made the TD15 incredibly durable under constant load. The undercarriage was equally impressive. Tracks, rollers, and frames were designed to absorb shock from rock-filled terrain and uneven ground. This allowed the TD15 to work effectively in quarry operations, dam construction, and large-scale land-clearing projects where lesser machines struggled or failed entirely. What truly defined the TD15 was its mechanical honesty. There were no electronics, no sensors, and no hidden systems. When something went wrong, operators could hear it, feel it, and diagnose it. Repairs were straightforward, often completed on-site with basic tools. This mattered enormously in the 1960s, when projects were frequently located far from major service centers. The TD15 helped carve highways, prepare industrial foundations, and move millions of tons of earth during a decade when the world was building at full speed. It wasn't refined, but it was unstoppable. Number 8. Komatsu D80 Early Series. The Komatsu 80 holds a special place in bulldozer history because it symbolized a major shift in global heavy equipment manufacturing. During the early 1960s, Japanese construction equipment was still viewed with skepticism outside Asia. The D80 changed that perception permanently. Komatsu approached bulldozer engineering with a focus on efficiency, balance, and manufacturing precision. The D80 wasn't designed to overpower competitors, it was designed to outwork them consistently. Its diesel engine delivered smooth, predictable torque, reducing drivetrain shock and extending component life. This was especially important on long-duration infrastructure projects where downtime was costly. Operators noticed immediately that the D80 felt more balanced and controllable than many Western machines. Blade control was smooth and responsive, allowing accurate grading and material placement. This made the D80 particularly effective in road construction and industrial development projects where precision mattered as much as raw force. Komatsu also focused heavily on durability. The undercarriage was designed to distribute loads evenly, reducing wear on tracks and rollers. Cooling systems were engineered for hot climates, allowing the machine to operate reliably in regions where infrastructure was expanding rapidly. By the late 1960s, Komatsu bulldozers were working not only across Japan, but across Asia, the Middle East, and export markets worldwide. The D80 helped establish Komatsu as a serious global competitor and helped build highways, ports, and cities that still serve millions today. Number 7. Allis-Chalmers HD16. The Allis-Chalmers HD16 was built during an era when bulldozers were expected to work hard, brake rarely, and forgive mistakes. This machine embodied that philosophy perfectly. In the 1960s, the HD16 became a familiar sight on dam projects, mining operations, highway construction, and large-scale earth-moving jobs. Its diesel engine was powerful, under-stressed, and exceptionally reliable. Allis-Chalmers engineers focused on longevity rather than peak output, allowing the HD16 to operate continuously under heavy load without suffering premature wear. This made it ideal for projects that required long working shifts and consistent performance. The drivetrain and final drives were built to handle shock loads from rock and heavy soil. Gearboxes were simple, strong, and tolerant of abuse. Operators could push hard without constantly worrying about mechanical failure, a crucial advantage in an era when productivity was measured in sheer volume of material moved. One of the HD16's greatest strengths was serviceability. The machine was easy to understand, easy to repair, and easy to keep running. Mechanics valued its straightforward layout, and operators trusted its predictable behavior in challenging conditions. The HD16 didn't rely on technology or complexity. It relied on iron, torque, and good engineering judgment. And through that simplicity, it helped shape infrastructure that still supports modern civilization. Number 6. Caterpillar D8 1960s models. By the 1960s, the Caterpillar D8 had already earned a formidable reputation, but this decade cemented it as the backbone machine for mega projects. When engineers planned dams, interstate highways, large reservoirs, and industrial zones, the D8 was often the minimum machine specified. It offered the rare combination of sustained pushing power, mechanical reliability, and serviceability that long, complex projects demanded. The D8's diesel engine was engineered for endurance. Rather than chasing peak horsepower, Caterpillar focused on torque delivery and thermal stability. This allowed the machine to push heavy loads for extended periods without overheating, crucial when projects ran around the clock. The drivetrain and final drives were massively overbuilt, absorbing shock loads from rock and compacted soil that would destroy lighter machines. Undercarriage design was another strength. Tracks, rollers, and frames were built to distribute load evenly, reducing wear and allowing the D8 to operate on rough terrain without constant downtime. On dam sites and mountain roads, where ground conditions changed hourly, this resilience kept schedules intact. Operators valued the D8 for its predictable behavior. Blade control was powerful yet precise, enabling both bulk earth-moving and controlled shaping of embankments and foundations. This versatility meant contractors didn't need separate machines for rough cut and finish work, saving time, fuel, and manpower. Perhaps most importantly, the D8 embodied mechanical honesty. There were no hidden systems. Problems announced themselves through sound and feel. Field repairs were common and effective, keeping machines productive far from major service centers. The 1960s D8 didn't just move earth. It enabled planners to think bigger, knowing the machine would keep up. Number 5. Fiat-Allis FD20. The Fiat-Allis FD20 represented a powerful synthesis of European engineering discipline and American heavy equipment toughness. As post-war reconstruction matured into large-scale development across Europe, the Middle East, and emerging markets, the FD20 became a trusted workhorse on projects that demanded reliability over long campaigns. Its engine delivered steady, controllable torque, ideal for sustained pushing rather than short bursts. Cooling systems were designed for hot climates, allowing the FD20 to work reliably in regions where infrastructure expansion faced extreme temperatures. The chassis emphasized stability, helping operators maintain control on slopes, embankments, and uneven ground. What set the FD20 apart was its consistency. Contractors valued machines that behaved the same way day after day, regardless of conditions. The FD20's driveline and hydraulics were tuned for predictable response, reducing operator fatigue and improving productivity on repetitive tasks like road formation and site leveling. Serviceability was another advantage. Components were accessible, and systems were straightforward, enabling field maintenance that minimized downtime. In regions where logistics were complex and spare parts took time to arrive, this practicality made a real difference. The FD20's global footprint is part of its legacy. It worked on highways linking cities, industrial parks powering economies, and ports connecting nations. Its contribution wasn't dramatic, but it was foundational, enabling steady progress across continents during a decade of rapid growth. Number 4. Liebherr Early PR Dozer. When Liebherr entered the bulldozer market in the 1960s, it brought a distinctly European emphasis on precision and control to heavy earth-moving. Early PR series machines demonstrated that dozers could deliver accuracy without sacrificing strength, a combination that proved invaluable on infrastructure projects where tolerances mattered. Liebherr engineers focused on smooth power delivery and refined blade control. Hydraulics were tuned for responsiveness, allowing operators to shape grades and foundations with confidence. This precision reduced rework and improved quality on roads, industrial slabs, and large building sites. Structural design was equally serious. Frames and undercarriages were robust, designed to endure continuous operation while maintaining alignment and stability. Cooling and filtration systems were optimized for dusty environments, protecting engines during long shifts. These dozers found favor on European projects, where space constraints and engineering standards demanded control. Rather than brute-forcing material into place, operators could work methodically, achieving consistent results that reduced downstream corrections. Liebherr's early dozers helped broaden the industry's view of what bulldozers could be, not just powerful pushers, but accurate shaping tools. That philosophy influenced later designs worldwide, raising expectations for control and finish quality in heavy construction. Number 3. Komatsu D155. The Komatsu D155 marked a decisive step into heavyweight territory. As mining operations expanded and earth-moving volumes grew, the D155 delivered the scale and durability required to support truly massive projects. Its large diesel engine produced sustained torque suitable for continuous heavy pushing. The drivetrain was engineered to manage immense loads without excessive wear, while the undercarriage spread weight effectively to maintain traction and stability. In mining and large infrastructure projects, the D155 proved invaluable for stripping overburden, shaping haul roads, and supporting excavation teams. Its productivity allowed fewer machines to move more material, a critical advantage where logistics and manpower were limited. Operators appreciated the machine's balance and predictability despite its size. Controls were straightforward, and the dozer responded consistently under load. Maintenance teams valued the accessible layout and robust components that simplified service in demanding environments. The D155 didn't just increase capacity, it changed expectations. Projects could be planned at larger scales, confident that machines existed to execute them reliably. In that sense, the D155 helped usher in a new era of industrial ambition. Number 2. Caterpillar D9. Early models. By the 1960s, the Caterpillar D9 had already begun carving out a reputation as one of the most powerful bulldozers ever built. But during this decade, it evolved into a machine that fundamentally changed what large-scale construction was capable of achieving. Where smaller dozers handled preparation and shaping, the D9 was brought in when the job demanded sheer dominance over terrain. The defining feature of the D9 was its ability to move enormous volumes of material consistently. Its massive diesel engine delivered relentless torque, allowing the machine to push through rock, compacted soil, and dense overburden that stopped lesser machines in their tracks. This capability made the D9 indispensable on mining projects, dam construction, highway cuts, and large industrial sites where entire landscapes had to be reshaped. Caterpillar engineers focused heavily on durability. The drivetrain, final drives, and undercarriage were designed to survive extreme stress for thousands of hours. Tracks were wide and heavily built, distributing weight effectively and maintaining traction even in unstable ground conditions. This allowed the D9 to work in environments ranging from deserts to mountainous regions with minimal adaptation. Another reason the D9 was so influential was reliability. In the 1960s, project delays could cost enormous sums of money. Contractors trusted the D9 because it kept working. Problems could be diagnosed mechanically, repairs could often be done on site, and the machine rarely suffered catastrophic failure when properly maintained. The D9 didn't just assist construction projects, it enabled them. Its presence allowed planners to design bolder cuts, larger fills, and more ambitious infrastructure. Many highways, reservoirs, mines, and industrial complexes that still operate today exist because machines like the D9 made them physically possible. Number 1. Caterpillar D8. Late 1960s evolution. While many bulldozers of the 1960s were powerful, only one can truly be called the machine that built the modern world, the Caterpillar D8. Its dominance wasn't about being the biggest or the strongest, but about being the most widely used, most trusted, and most adaptable heavy earth-moving machine of its time. The late 1960s D8 represented the peak of purely mechanical bulldozer engineering. It combined immense pushing power with reliability that contractors could depend on across years of continuous operation. Its diesel engine was tuned for endurance, not short bursts of output, allowing it to work day and night on major projects without overheating or excessive wear. What truly set the D8 apart was its universal application. It worked on highway systems that connected cities, dams that controlled rivers, airports that enabled global travel, and industrial zones that powered national economies. Unlike ultra-large machines that were limited to specialized jobs, the D8 was versatile enough to appear on nearly every type of major construction project. The undercarriage design allowed it to operate effectively on uneven, rocky, or unstable ground, while its blade control offered both brute force and precision. Operators could clear forests, cut roadbeds, and finish embankments using the same machine, an efficiency that accelerated project timelines worldwide. Perhaps most importantly, the D8 embodied trust. Engineers planned projects knowing the D8 would perform. Contractors bid jobs confident the machine could handle the workload. Operators relied on its predictable behavior and mechanical honesty. When something went wrong, it could be fixed without waiting for specialized tools or electronic diagnostics. The world we live in today, its roads, dams, industrial centers, and infrastructure rests on foundations shaped by the Caterpillar D8. More than any other bulldozer of the 1960s, it turned ambition into reality. Those bulldozers didn't just move Earth, they moved humanity forward. Every road, dam, city, and industrial project built after them stands on ground they first shaped. They proved that strength, simplicity, and reliability could change the world. Which of these 1960s bulldozers do you think had the biggest impact? Drop your pick in the comments. I read every one. If you respect heavy machinery, real engineering, and the machines that built civilization, hit like, subscribe, and stay tuned. Until next time, respect the iron that built our world.